Good morning, children. Today we'll discuss another activity from your book. In the last video we have discussed about this activity. Today we will going to discuss about formations of precipitate. Precipitate. It is an insoluble substance. In some chemical reactions, when two solutions are mixed together or a gas is passed through a solution, an insoluble solid substance formed. Insoluble. This is known as precipitate. It is in the solid state. For example, when silver nitrate solution, it is clear aqueous solution, silver nitrate aqueous solution is added to a solution of sodium chloride. A white precipitate of silver chloride is formed. Now the arrow pointing downwards represents the precipitate, and precipitate is the insoluble solid substance formed when two solutions are mixed together, and this sodium nitrate that formed is another product. It remains in the solution. In your next page, there is an activity to demonstrate that some chemical reactions are detected by the formation of precipitate. And for this activity, potassium iodide powder, Ki powder, that is white, lead acetate powder, also white in color, a test tube, a beaker, and water is required. This water acts as a solvent. Potassium iodide is soluble in water. Lead acetate also soluble in water. We have to first mix potassium iodide powder with water and lead acetate powder with the water to form a clear aqueous solution of potassium iodide and a clear aqueous solutions of lead acetate. Procedure: put potassium iodide powder in a beaker containing water and you have to form a clear solution. In another test tube, take lead acetate powder, add water to make a clear solution. Remember, lead acetate is in the test tube. Shake the test tube well to form the solution. Now pour lead acetate solution into the potassium iodide solution, not the potassium iodide solution to the lead acetate solution. Now pour lead acetate solution into the potassium iodide solution. What you will observe in this video, we will going to show this one. Now this is the lead acetate solution. This is your potassium lead. In this case, we take lead nitrate solution. You can imagine in your book that this is the lead acetate solution as well. Also, you can take lead acetate solution, and this is the potassium iodide solution. These two are the clear solutions. We don't have the test tube to form this one. Prepare this one in the beaker. Now add these two solutions, lead nitrate solutions here and potassium iodide solutions here, these two clear solutions. And by the definitions, you know that precipitate means an insoluble solid which formed when mixing of two clear solutions. Now look at this. When you mix this one, a yellow color precipitate, insoluble solid formed. This is the formations of lead iodide. So what you have observed, that you will observe the formations of yellow colored precipitate. This is clearly mentioned in our book. And conclusion, that some chemical reactions are characterized by the formation of precipitate. And this yellow color precipitate that formed, it is the lead iodide. You have to mix lead acetate solution to the potassium iodide solution. And the word equation, potassium iodide, colorless. You have observed lead acetate also colorless. AQ means aqueous solution, that is solutions made in water. Lead iodide yellow precipitate form and lead acetate a colorless form. This remains in the solution. Another characteristic is the heat absorbed or evolved. Almost all chemical reactions take place with absorptions or evolutions of energy in the form of heat. Heat absorbed means endothermic reaction. We have discussed in the second video made for class 7. We have discussed this one, endothermic reaction. Chemical reactions in which heat energy is absorbed by the reactants is called an endothermic reactions. Nitrogen, oxygen are the reactants, nitric oxides are the product. They react together, nitrogen and oxygen react together to form nitric oxide when they are heated to a very high temperature, near about equals to 3000 degrees centigrade. Since heat is absorbed, this reaction is referred as an endothermic reaction. In our SCI vocab, a chemical reaction in which heat energy is absorbed by the reactants is called an endothermic reaction. You can also write these equations as a nitrogen plus oxygen gives nitric oxide minus heat. That means they are absorbing heat. Another examples of an endothermic reactions, it is given in your book that calcium carbonate is heated about 1000 degrees centigrade. It decomposes into the calcium oxide and carbon dioxide. Calcium carbonate plus heat gives you calcium oxide and carbon dioxide. In the second video also we have discussed about an exothermic reaction, a chemical reaction in which heat energy is evolved or released along with the formations of products is called an exothermic reaction. An exothermic reaction causes rise in temperature, but for the case of endothermic reaction causes fall in temperature. However, for example, when calcium oxide, look at the example, calcium oxide, when react with water, it will form calcium hydroxide and huge amount of heat is evolved. The solid calcium oxide is referred as a quicklime, and the solutions of calcium oxide plus water gives you calcium hydroxide. It is termed as slakelime. Look at this video. This is a simple water. You are adding calcium oxide solid, quicklime. You are adding quicklime. Look at this. What happened to this water? And it starts boiling. Literally it starts boiling. Look at this. Highly exothermic reactions. Is the boiling. Please don't try this in your home. Just literally boiling. Start boiling. So this is the calcium oxide. When react with water, it will produce calcium hydroxide and huge amount of heat is released. That's why it is termed as an exothermic reaction. Heat evolved, and this heat evolved, and the boiling of this water is due to the generations of huge amount of heat, which boils the water. It is also mentioned in your book. Another example, when nitrogen reacts with hydrogen to form ammonia, heat is released. It is important to remember that for the case of that endothermic reactions are represented by writing plus heat on the reactant side. Look at this plus heat. If you write plus heat, you have to write on the reactant sides. If you want to write minus heat, you have to write on the product side. But it is reverse in the case of the exothermic reactions. In exothermic reactions are represented by writing plus heat on the product side. If you want to write on the reactant side, you have to mention minus heat on the reactant side for the case of exothermic reactions. Other two examples, the most important examples of the exothermic reactions are the combustions of fuel. Combustions are generally of two types, partial combustion and total combustions. These are combustions of fuels, rusting and respirations. And these are termed as an exothermic reactions because during the combustions of fuels, during the rusting of metals or during the respirations, huge amount of heat energy is evolved. These are defined in your SCI vocab. A chemical reactions in which heat energy is evolved or released along with the formations of products is an exothermic reaction. Combustion, this is the process of burning. Respiration, in your biology class you have learned this one. Respiration is a process in living organisms involving productions of energy. Chemistry is definitely related with the science, other branches of science like biology. Next activity, aim to show that heat is evolved in some chemical reactions. It is in your book. Materials required: hydrochloric acid, sodium hydroxide, plastic beaker, thermometer and measuring cylinder. Measuring cylinder are used to measure the chemicals. How much volume we require, 10 ml, 20 ml, 50 ml, like this, milliliter, these are in the volume. Procedure: measure 50 milliliter of hydrochloric acid, 50 milliliter. This is graduated beaker. With the help of this beaker you can easily measure this one, like 10, 20, 50, like this way. Measure the temperature of the acid using thermometer. They have used thermometer. Look at this figure 6.5 in your book. Measure the temperature of the acid using thermometer and note it as T1 temperature, that's why it is T1. Now measure 50 milliliter of sodium hydroxide and add it into the plastic beaker containing hydrochloric acid. This is the sodium hydroxide mentioned. To add this sodium hydroxide into this plastic beaker containing hydrochloric acid, and initial temperature was T1 measured by this thermometer. Note down the temperature of the mixtures of hydrochloric acid and sodium hydroxide as T2. After mixing you have to measure the temperature again and note it down as T2. You will observe that T2, that is the temperature after mixing sodium hydroxide with hydrochloric acid, will be higher than that of the T1, that is in the initial stage, that is temperature has risen. As heat is evolved, there is a rise in temperature. Okay, this is an exothermic reactions. There is a life skill while performing experiments in the chemistry lab. You are handling chemicals, of course, and you have to prepare safety measures. That is included in your syllabus, life skill. And the last part of your chapter is the chemical equations. We have learned about that word equation. We've heard at the reactant, product. Chemical equations is the symbolic representations of the chemical reactions. That is actually the word equation. By using symbols and formula of the reactants and the products. Look at this example, zinc and sulfuric acid. When react, it will produce zinc sulfate and hydrogen gas. This is actually your word equation. Now symbol of zinc is Zn. Formula of sulfuric acid H2SO4. Formula of zinc sulfate ZnSO4. Formula of hydrogen gas H2. So you have to write Zn instead of writing ZINC. You have to write H2SO4 instead of writing SULPHURIC So these are your word equations, and this is your symbolic representation of this word equation, and this is the chemical equations. There are two parts of these chemical equations. The left hand side or LHS and the right hand side RHS. Left hand side is the product, left hand side is the reactant. The reactants are written on the left hand side and the products are written on the right hand side. These are the products and this is the reactant side. The formation of products is shown by the arrow pointing towards them, towards product. Okay. So we have come at the end of this chapter. There is a rapid revision. From the first video to this video, we have learned so many things: reactant, products, precipitate, exothermic reactions, endothermic reactions, and all. Okay, children.